Good morning, all of you. I'll be starting with a new module today. Its name is Operational Amplifiers. So, here the operational amplifiers in short is written as op-amps. You may be seeing here op-amp stands for operational amplifiers. Now, the operational amplifiers definition is an op-amp happens to be a directly coupled multi-stage voltage amplifier with extremely high gain. So we call it directly coupled because one stage is providing the output to another stage. Every time, if at all, I can show you using a block diagram. If this is the first stage provides the output to the next stage as an input. This stage provides the output to the next stage as an input, and the output of this stage is given as an input to this, and this keeps on continuing. That is why, as one stage is providing the input to another stage, we call it directly coupled. We call it multi-staged because it is not just one amplifier which is involved, but there are multiple amplifiers which are connected in cascade. That is why we call it multi-staged. There are lots of voltages involved here, and that is why we call it a voltage amplifier, and this has extremely high gain. So one thing what we should remember here is it is named as operational amplifier. Amplifiers work basically is to strengthen the weaker signals. Whenever it is strengthening the weaker signal, we know that the output happens to be very much greater when compared to the input. If at all output is greater when compared to the input, gain is always output upon input. Whenever output is higher when compared to the input, gain will be obviously more. That is why it is extremely high gain. So let me again repeat. The definition of an op-amp is it is a directly coupled multi-staged voltage amplifier with extremely high gain. So now, if at all you want to control the behavior of an op-amp, you are supposed to connect a suitable feedback. About this I'll be explaining as and when required, but as of now you can understand it in this particular way. If at all you want to control the behavior of this particular op-amp, you're supposed to connect a suitable feedback. Next is, op-amp has got input and output stages. So the input should be having high input impedance and the output should have low output impedance. So impedance here basically is a resistive factor. So the input impedance has to be very much greater. The output impedance has to be very much lower. Now let me show you the symbol for an op-amp, how the op-amp looks like. This basically is a symbol for an op-amp. When you see this particular picture, you will understand that op-amp has got two inputs. The first input is negative, the second input is positive. You can just interchange this also. There is no difference that it is going to make. You can make the positive up and negative down, then also it is absolutely okay. So one thing you should remember is the negative terminal is called as the inverting terminal. The positive terminal is called as the non-inverting terminal. Here the negative terminal is termed as V1. The voltage offered by the negative terminal is V1. The voltage offered by the positive terminal is V2. So now V1 is the inverting input and V2 is the non-inverting input. Now there are two power supplies. The first power supply is called as V plus, which is positive power supply, and the second power supply is called as V minus, which is called the negative power supply, and there is output which is represented by the term V naught. Now all of these are voltage terms. You may be now understanding why it is called as the voltage amplifier. The two voltages at the input V1 and V2 will be amplified at the output, and basically the op-amp is called as a difference amplifier, which means the difference between the two inputs will be amplified and given as an output. So let me now move ahead.